Okay, for problems 25 and 26, we're asked to write the slope-intercept form of the equation of each line. Well, we remember that for slope-intercept form, we have y equals mx plus b, with m being our slope and b as our y-intercept, hence slope-intercept format. Okay, so let's find our m and our b. Well, our b is easy. It's our y-intercept. So we have our y-axis up here. Where does our line cross our y-axis? Down here at -5. So our y-intercept is -5. Okay, what's our slope? Well, to find our slope, we need 2 points that our line goes through. It goes through this point right here, which is 0, -5. Now let's find another point. Goes through this point right here, which is 1, 3. So let's count. Our rise is 1, 2, 3, 4, 5, 6, 7, 8. And our run, well, we went 1 to the right, so that's positive. So we can just write that as 8. 8 over 1 is just 8. So let's plug in our m and our b. Our m is 8, and our b is -5. So the equation of our line is y equals 8x minus 5. Okay, we're asked to find the slope of the line through each pair of points. Well, if we remember, every point has an x and a y. Now, we had this equation which was delta y over delta x, which is y2 minus y1 over x2 over x2 minus x1. Well, we've got to define ones and twos. We get to pick. Doesn't matter which point is which. I'll make this 1. So that means this is the second point. Okay, so our change in y. So y minus the other y. So 15 minus 11 over 15's x is 6 minus the other x is 5. Well, 15 minus 11 is 4, and 6 minus 5 is 1. 4 over 1 simplifies to just 4. So the slope of the line that passes through these 2 points is 4. Okay, we want to write the answer as a sum. So that means we're trying to multiply these two binomials. We multiply binomials using a generic rectangle. Binomial meaning two terms. So I have x plus 6 times 5x minus 5. So 5x times x is 5x squared. 5x times 6 is 30x. Negative 5 times 6 is negative 30. And negative 5 times x is negative 5x. So on the inside, I have 5x squared plus 30x minus 5x minus 30. I need to combine like terms. So this plus 30x and this minus 5x combine. So I end up with 5x squared plus 25x minus 30. And that's my answer as a sum. Okay, I'm asked to solve a proportion. This is the one and only time that I get to cross multiply. So I'm going to have 3 times 8 is equal to 4 times the quantity m plus 4. 3 times 8 is 24. I need to distribute here. So I have 4 times m is 4m plus 16. I'm going to subtract 16 from each side. That gives me 4m is equal to 8. I have 4m, I only want m, so I'm going to divide both sides by 4. And I'm left with m equals 2. M equals 2. Okay, this says write the slope-intercept form of the equation of each line given the slope and the y-intercept. Well, this is the easiest type of problem you can be asked because it gives us a slope and a y-intercept. And we know that y equals mx plus b. M is our slope and b is our y-intercept. So all we have to do here is just plug it in. Y equals, well, our slope is negative 4/3. We're going to bring down our x plus 0 since our b is 0. Well, we don't even need to write the plus 0. So we're just going to rewrite it once more as y equals negative 4/3 x. That's our equation. We're done. The last problem for the odds, we're asked to write the slope-intercept form of the equation of the line described. So we want it to go through this point right here. We want it to be parallel to this line. Well, how do we do this? We know that parallel lines have the same slope. So that means the slope of my new line is going to be the same as this slope. So the slope of my new line is going to be negative 4. But I also need to have b. I don't know that yet. How am I going to find that? Well, I have an x and a y. So I'm going to plug these in. Y equals mx plus b. I know that my y is negative 1 because it has to go through this point. I know my m is negative 4. My x is negative 1. And I'm trying to figure out what my b is. So negative 1 is equal to negative 4 times negative 1 is positive 4 plus b minus 4 from each side. B equals negative 5. So my equation of this line is y equals negative 4x minus 5. That's the equation of my line.